Hello, this is video 6, and in video 6 I'm going to get the ball rolling. I don't think I'm going to finish it, but I'm going to get started on lab 1. Now, before I get started and before you get started, lab 1 is where you find out how much you have figured out so far about recursion and all that. So if you haven't even started on lab 1 yet, cut the video off now. Don't even watch any of the rest of it, because it's not only going to steal all your fun, but as secrets are revealed about how you go about this trace and everything, if you haven't figured it out on your own, then you won't derive maximum benefit from the video. So for your own good, if you haven't done lab 1 yet, then maybe hold off on watching this until you've given it a shot. I'm going to do this with lab1.cpp in hand. Of course I am. Otherwise I'm not going to be able to trace it. So if you don't have a reference copy that you're looking at when I start referring to line numbers and stuff, this is not going to make any sense to you. Okay, at the top, lab 1, yada, 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 call a recursive function. What's the output? All the other stuff. Max level is 3. I guess if this is going to be a complete trace, I'll put that up here. Max level. Whoops, not like that. Silly me. I've only had 1 cup of coffee. There, I said it. That is almost certainly not going to be enough. I might have to start this video again. I've started lots of videos over. Okay, max level is, why did I put it way over there when we know the whole reason we're here is we're going to have the program stack, abbreviated prog stack. It's not much of an abbreviation, is it? The prog stack is going to be over here, and it's going to grow and grow and grow and grow, and there's no point in putting it off. Why don't I put max level over here? Quit fooling around. Well, max level is not over here. Max level is in the initialized data segment, far, far away from the program stack. So who does go in the program stack? Recall the local variables, the parameters that are passed in, and invisibly to us, it also puts the return address, where to go back to after the function is finished, where to return to when it hits a return statement or it hits the closing curly bracket. So that's not inappropriate to put max level way over there in the corner. Go sit in the corner, max. Okay. Prototypes, rect function is going to have 2 parameters, depth, line to return to. I'm going to try to make those as self-explanatory as I could. Blanks takes an unsigned value. If you haven't seen the data type unsigned before, don't get scared. It just means integer that can only be positive. The smallest possible unsigned value is 0. If you remember 2's complement as a number representation, unsigned ignores 2's complement. All the little bits in an unsigned value contribute to the magnitude on the place value chart. So there are no negatives of unsigned. Anything that you know is never going to be negative, you could make it unsigned, and it might run a little more efficiently. And you also gain the ability to represent bigger numbers. And I'm so far off track. Let me get back to lab 1, shall I? Here's what we got to do. We got to keep up with what's going on in the program stack. We also got to show what the output is. And I'll just put those side by side. That's all we're worried about. And the lab 1 assignment, kindly, mercifully, you're welcome, does not require you to keep up with the calls to blanks. You just have to take a peek and see what that happens when blanks are called. But the reason I'm not going to put blanks over here is because it would make at least double the size of the program stack to keep up with all the stack frames for all the calls to the blanks function. And also blanks is not recursive. So it's no fun. There's no point in doing stuff that's no fun, huh? So here we are in the main program, and it starts off right off the bat with the cout statement. Cout, main says, like so, and I'm going to run out of space. Going to rect func from line 23. Let me write smaller. There, I did it. Dot, dot, dot. In line, so it's going to go to the next line with whatever output is produced next. And away we go. You know what? I've got to put my glasses off or I'm not going to be able to read this. Line 23 is the first call to rect func. So that's the first place where we need to keep up with the stack frame. There is already a stack frame over here, but we're ignoring that as well. The first stack frame is always going to be your main program. It is a special case of a function, just like all the other functions you call. So it has like a stack frame that's permanently attached to the bottom of the stack until the whole program finishes. I'm not illustrating that. We know that, so that's irrelevant to what's going on here. Now it calls recfun from line 23, and we drop down to recfun and see where the 1 and the 23 are going. Recfun is on line 42. 2 parameters. Those parameters are in the stack frame. That's the whole point, that we need a stack frame for recfun, to hold those parameters and any local variables that show up. I don't think this one has any local variables, but it certainly does have those 2 parameters, depth. Holy moly, I'm not going to write this out every time. Line to return to, you know what, I'm going to abbreviate that and just call it line. Depth and line. There. The stack frame with the automatically allocated, this is storage class automatic, by the way. Storage class automatic is fighting for memory with storage class dynamic. Sounds like dynamic ought to win that one, huh? That's more like a superpower. Dynamic is the stuff that you get by calling new. Dynamic is the stuff you ask for and have to remember to return when you're done, else you have a memory leak. Automatic, the system giveth and the system taketh away. The system giveth by allocating a stack frame for the variables for storage class automatic, and then it automatically takes those back when we return from the function. They magically disappear, is how I like to describe it. Get going, my goodness, what was passed in on depth and line 1 and 23? There. Shut up and trace. Okay, line 43. It's not labeled as such, is it? That's probably a bad thing. Yeah, because I did label the recursive cases. I should slip in a comment there. Haste makes waste, but that's the base case. The base case, you want to test the base case right off the bat to see if you need to get out of here. Otherwise, you risk calling, a recursive function risks calling itself in an infinite loop, which will eventually use up all available memory in the stack, even if it doesn't do anything, because the system has to keep making a stack frame for each recursive call. I am getting so off track this morning. Now, line 43, if depth equals max level, does not. Depth is 1, max level is 3. So it skips the if, it doesn't do the return, and here we get a cout statement on line 48. Here's what blanks is for. Blanks is just to make the output a little more illustrative of how deep we are in the recursion. So when it prints out blanks depth, if we just take a quick look at the blanks function itself, it's expecting an unsigned value, and it gets it. I should put a stack frame here with a value of n of 1. What does it do with its value of n of 1? Well, it starts off a string that's an empty string. Those double quotes on line 32 are right next to each other. So I'm initializing a string of blanks variable to be equal to the empty string. Then I start a for loop. For I is 0, I is less than n, plus plus I, yada, yada, yada. We've seen that before. That's just a loop that's going to execute n times. So in this case, it's going to execute 1 times. What is it going to do? It's going to take string of blanks, whatever's already there, and append to that. It's almost like a running total of blanks in a way. So what it appends to that, plus equals, that's equal to a string of blanks equals string of blanks plus, and that is a string of 5 blanks in there. See what's going on here? We started with a running total blanks of 0, an empty string. And every time we go through the for loop, it's going to stick 5 more blanks onto that. And when it's built the whole string of however many blanks we need, n times 5 blanks, then it returns it. And when we return it, it lands smack dab on line, wherever we were. I lost my place, line 48. And it just prints out that many blanks. So it's going to skip over. I'll do a line to represent explicit blanks there. There, that is 5 blanks. So it skips over 5 blanks, prints out depth. The value of depth is 1, colon. Just got to level depth. So depth gets printed out twice. Why did I print it out 2 times? Well, over here, this is just kind of a label to show which of the recursive calls that we're in. And this is a message to say how deep we are in the recursion. I guess it's redundant, but still, I hope it's, the intent of this program was to make a difficult topic. Recursion is hard. I admit it. Try to make that as clear and lucid and understandable as possible, and perhaps I have some success, perhaps I have some failure. But that was the intent, and that was line 48, and we keep going. Recursive case, first recursive call, and it prints out blanks again, and it prints out depth again. The blanks and the depth over here, they're just, that's just like an eternal label inside this function call to show how deep in recursion we are right now for the statements that are executing. And it prints out depth again. I'm on line 51. Prints out depth is 1. Whoops. I just now did that. Blanks, and then 1, and then colon. Going to recfunc from line 52. That's a 52. A hideously ugly 52. That's a better looking 52. From line 52, dot, 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 end line. Okay? You have no idea how close you were to getting the example program last night that I had dashed out that had line numbers wrong all the way through because I hadn't put all the comments in yet. And I forgot to go back and change those. It still has the wrong output at the bottom. Did you figure that out? That was the output from a previous program that I plagiarized from and just overhauled it into Lab 1. A little history lesson there. Then there's a call. Look at this on line 52. Sure enough, going to recfunc from line 52. There is a call on line 52 to recfunc, which means it's got to make a new stack frame. Bye-bye, first stack frame. We can't see you anymore. We can only see this one. And it's passing in depth plus 1. Notice it's not changing the value of depth. It's just adding 1 to it. The compiler will evaluate that expression and send that, or the system evaluates that expression and sends that down to the next function call. I'm going to start abbreviating these variables right away. Oh, depth of line, I can write that. Depth line. Yes, there is a limit to how lazy I might be. We passed in depth plus 1, which is 2. Depth plus 1 is 2. And we passed in 52. Now, just as I did when we were tracing a recursive function before, I'm going to invite you to clear your mind. Recfun, what's that? I've never been there before. Lucy Ricardo with amnesia. I've just now gotten to line 42, and I've got a brand spanking new set of local variables to look at. The parameters, depth, and line to return to. I don't have to keep up with anything that's gone on so far. This is fresh as a daisy. If depth equals max level, is 2 equal to max level? 'Tis not. So we have not hit the base case yet. It skips over the if down to line 48. And now it calls blanks again, except this time it calls blanks passing in 2, which if you understood blanks the first time around, what that's going to do is print out 10 blanks in a row. There's 5. There's 5 more. And I am really running out of board space, I know. And then it prints out depth. I'm keeping my thumb so I can keep up with the next instruction here. Depth is 2. Colon is colon. Just got to level. There's no reason for that T to be over there. Just got to level. And prints out depth is 2. In other words, we are now 2 stack frames deep in our recursive calls. We just got to level 2. Recursive case. See out the blanks, depth. Depth. We pass in depth to blanks. We're ignoring this. Notice me totally ignoring this. I don't want to exit out because it's still active. It's just not the visible stack frame yet. This is the only one. The bottom one that's not X'd out is the only one the system can see. So there is no ambiguity. It knows which depth we're talking about on line 51. And is that the one I'm ready for? Yeah. Line 51, it prints out 10 blanks. It prints out depth, which is 2. And says, what, on line 51? Going to recfun from line 52. This is what you're supposed to be doing for Lab 1, by the way. I'm not just drawing all this stuff on the board to entertain myself. This is the kind of stuff you're going to need. You need to show what the output is. You need to keep up with the stack over here. And away we go on line 52. Let's call function rec fun. That sounds like a fun place. Recreational fun. Let's go there. Let's pass in depth plus 1, which will be 3. We're passing in a 3. We're passing in a 52 from line 52. So here we are. We're calling a function. And this is a cool place we've never been before. It's receiving a 3 and a 52, this recreational fun function on line 42, and it's putting them in its parameter variables depth, the 3, and line to return to, the variable name too long to write, is 52. Why did I put the line numbers in there? Well, remember I told you part of what goes into the stack frame is the return address. That's one of those wild and crazy hexadecimal numbers. It's the actual machine address of an instruction in memory, where to go back to. This is the closest approximation I could come up with. This is the line we will go back to, which we'll say is standing in for the actual address. So rather than print out messy, scary hexadecimal addresses, we're keeping up with which line in the program it goes back to. There, that's what that was all about. Okay, here we are, fresh as daisies again, on line 43. If depth is exactly, oh, look at this, look at, ding, ding, we have a winner. Depth is exactly equal to max level. So things change a little bit. See out blanks depth, oh dear. Depth is 3 this time. So if that's 5 and that's 10, then this must be 15. Yeah, we're gonna need to expand the whiteboard over there. 15, depth is 3. So it prints out 3 and a colon, and it says hit maximum recursive level. I'm going to have to abbreviate or it won't fit, I'm sorry. Hit max rec lev. Everything is a 3-letter word. Hit maximum recursive level, and then it prints out depth 3. And still on the same line, it prints out back out. Watch this, back out. That says back out with an exclamation point. You're just gonna have to believe me. I know that's too tiny to read. I've got to get this close to read it. But that's the output that's produced by the never-ending cout statement. Starts on line 44. Okay, and still on the same line. You know what? I'm going to have to do wraparound here. This will be my wraparound. I'm still on the same line, returning to line. Please don't do this in your trace of the output. See if you can space it out so that you can fit all that on the same line. This is just poor planning ahead on my part. Returning to line, and finally we look at line to return to. Line to return to is 52 in this case. Returning to line 52. So the function is about to return because it hit the base case, and it's telling you where it's going to go back to. Remember, the reason that the system has to keep up with where to go back to is because, let's look at this. There's a call to rec fun on line 23. There is one on line 52. There's one on line 57. It could have come from any of those. So the system's got to keep up with the return address. It needs to know which line to go back to. Here, we're going back to line 52. And I've lost my place. I back out, return in line 52. Then on line 46. Okay, there's a big stuff going on line 46. Well, not huge stuff. But when we return, pop. When we return, we're no longer in that particular function call, We just finished printing out all that junk for level 3, back out, returning to line, all that stuff. When it returns, we are leaving the function. We're leaving the function that we just now started executing with line 42, and we're going back to line 52, apparently, in the program. That's who called us. But on the way back, it pops off. Please X these out. Don't erase them from your trace. X out the stack frame. That makes this one visible. So now, when the system runs into variable depth and line to return to, it's going to think 2 and 52 rather than whatever was in this stack frame. Okie doke, we're returning to line 52. So now, oh, I wake up. I was asleep. Excuse me there, I was asleep in the stack. Let me wake up and pick up where I left off. I just got back from the function call that I made on line 52. So now I'm ready to do line 53. Line 53, print out blanks depth-wise. Okay, depth is 2. 2 times 5 blanks is 10. So we're back to a shorter line, thank goodness. And the depth is 2. And it prints out colon back from rect fun to line 53. Back from rect fun to line 53. It's trying so hard, bless its little heart, to show you exactly where it is in the lineup, how deep it is in the recursive calls, which line it is in the program. Other than that, this program is totally artificial. I mean, its only reason for existence, feeble as it may be, is to illustrate what happens when a recursive function operates. Okay, I keep getting off track. A good thing I'm using my thumb to keep up with which statement we're on. We just got back from rect fun line 53. Recursive case, second recursive call, see out blanks depth. Depth, the only depth it can see is 2. So twice 5 blanks. That was fun. Well, was it? I don't know. It says that was fun. Depth 2. That was fun. I don't remember when I had so much fun. Tell you what, with coronavirus, the bar for fun has been lowered significantly. So maybe that was fun. That was fun. Let's go to rect fun again. I'm going to have to abbreviate that or it won't fit. Let's go ... And where do I come in for a line? Let's go to rect fun again from line 57. Please do as I say, not as I do. Please start far enough to the left on your paper where you're showing the output. Actually, you know what? If this is on a piece of paper, you might even want to do separate pieces of paper for the output and the stack, so you've got room for everything. You don't have to abbreviate and cram everything together. Where's the let's go? Let's go, line 57. It's got to be near line 57, huh? Then it calls rect fun again on line 57. Now look at this. When we call rect fun, we're passing in depth plus 1. It's this depth. So we're passing in 3 and 57. Look how I'm doing the stack frame. Three, 57. The reason I did it like this is so that I can see that I had a stack frame for a function call that I went to and came back. It got popped off. The system, the real life system, on the other hand, once you pop that off, that's available in the stack. And there's almost 100% probability that this stack frame, would actually occupy the same storage that that previous one did. That's what I meant by don't erase this. That's what the system does in effect. It in effect would erase this stack frame and then reuse that storage the next time you call a function. That is not very enlightening for a trace, though. If you want to be able to go back and make sure that you did your work correctly and see exactly what was going on in the recursive function calls, after you've popped it off, you just continue on downward. I mean, that's a little artificial, but it's much more, I think it's much more enlightening for how this actually works. Okay, we're starting all over again. I think all I did was just now draw that stack frame. So it starts at the recursive function all over again with depth equal to 3, line to return to be 57. If depth equals max level, and in fact it does. Max level is 3, depth is 3, so here we go again. Blanks depth is 3, 15 blanks over, 5, 10, 15. And it prints out depth, which is 3, colon, hit max rect level. Writing gets worse as we get further down on the board. Hit max rect level 3. Back out. I'll do another tiny back out for old time's sake. Back out! Exclamation point. Go back, go back. Returning to line, it will print this. I'm just going to have to say it. Returning to line 57. So here we go. Here's the first time that we're going back to a different line than we came from before. So it's returning to line 57. I'm going to have to put that up here. This is much messier than I had envisioned, but I hope you can still follow it. Returning to line 57. In return, when it returns, this one didn't last very long, did it? That gets popped off, and it goes back where it came from, which is the call. It's actually the second call to the recursive function that thinks that the depth is rightfully 2 and the line is rightfully 52, except we're picking up where we left off on line. Look at this. We go back to line 57 this time. That's why I put the line number in there, so we can keep up with where we got to go back to, just like the system does. And when we do that, go back, then it prints out the blanks. Blanks of depth is twice for 10. I'm about to run out of board space, and we're about to the bottom of the function anyway. I lost my place. Line 57. We just got back. Depth, I just now did that. Depth is 2, colon. It prints out back from recfun to line 58, and we're returning to line. Back from recfun to line 58. That's where we are. I've got to do the wraparound. Sorry about that. And we're returning to line we are returning to line to return to. I had to look over here. The only one that makes any difference is the bottom one. Oh no, do I return line 57, line 23? I don't know. The one here on the bottom is actually on the top. This is the one that's on the top of the stack. So that's the only line to return to variable that the system can see. That's why I'm doing this trace this way, so that I can see it myself. 52. And you'll notice, even though there's depth and line to return to all over the place over here, only one of them can possibly be visible and active at one time. Whichever one is on top of the stack, whichever one corresponds to the currently active function call. So we've reached the bottom of the function, and then it's going to pop this off. It's going to return to line 52. Pop. Now we're back to line 52. Where am I? What's going on? Well, when I go back to line 52 and pick up where I left off, notice on line 53, it's going to print out blanks of depth. We're back to just 5 blanks. 5 blanks all the way back. Look at this zigzag back and forth like that. We're back to 5 blanks, and it prints out the depth of 1. And what did I go back to? I went back to line 52. Depth of 1. Back from recfun to line 53. And on line 53, after that, then it's going to do the that was fun, let's go again thing. Yada, yada, yada. I'll leave the rest. I mean, this was an exercise anyway. But I mainly wanted to illustrate what's going on with the stack over here. Now, when this turns around, when this one, which it's about to do, it's just always up to trouble here. When it turns around and makes another recursive call, then it's going to have to allocate another stack frame for that recursive call. I predict it's going to be something like with depth of 2 and line number. I'm not even going to figure that out, but that will be stored in a separate stack frame because it's turning around and making another recursive call. Now, if you feel as if I'm leaving you high and dry, I am not. The program that I sent you, it better be a version that actually runs. So I would say, first of all, try this by hand, and if you can't figure out how to proceed, then watch this video. That's strange advice to give at the end of the video, huh? And then, if you want to double check, especially your output over here, double check that by running the program, and it actually will generate the output that we're predicting here, if we're doing this correctly. And I'm gonna, I'm gonna have to check this against the output after I close down the video. I'm gonna leave this on the whiteboard and see if this is actually correct. If it's not, then you're not seeing this video anyway, so don't worry about it. But there we go. There's a kickstart, a jump start for Lab 1, and I shall see you online.